Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a different concept in the measure of variability and dispersion. Of course, this is a concept in statistics that we have already discussed in one of our videos. But we're going to have a recap using the table that I've given on the board so that we can be able to acquaint ourselves and try to get the concept that's under discussion for us for today. So without further ado, thank you and welcome. So from our previous videos when we were trying to talk about the measure of variability and dispersion, we learned about a new concept that was the measure, the mean square deviation that we had derived from this specific table. Now, the range of values that we have given in this table is the value for x. This is data, and then the x minus that second value. This is a set of data that we said, and then this is what we called deviation. And this deviation implies that a particular set of data is having a difference or a spread out from the mean value. And for our case here, we have said that the mean is given as the summation of fx. This is from I to n over the summation of frequency from I to n. So for our case here, this is going to give us, of course, what we call the mean. Therefore, for our case here, the mean was 10.8. So we are just going to do a summation for the frequency times. In this case, each of these data has got a frequency of 1. Therefore, the total for this is going to be summation of all these data right by the summation of frequency, which is going to be 5. So in this case, we are going to see that the difference between this value of x and the mean gives us the values that we have already put in this second column of our table. So therefore, for each respective value is the difference between the value and the mean. Now, the absolute deviation, which we have given in our third column, the absolute value, when we say about the absolute value, which is given using that symbol, if we say x is equals 5, and the absolute value for this is given as this, which is 5. Suppose the x is equals to -5, and we do a substitution for that. The absolute value for -5 is a positive 5. So this will imply that the ranges of value that appears in the second column are just implied as positive values after we have found the absolute value for this column. So therefore, the last column is a square of the absolute values of that deviation. And therefore, we say the mean square deviation was given as, so we are going to define the mean value deviation using that symbol, the root, the x, the square of x, and then we said it's a summation from I to n over fi, and then this is the absolute value, of course, from this to this one of the means squared, and then the summation of frequency from I to n gives us what we call so this is from the 1 to I3. So that's the range of values. So that one gives us what we call the mean square deviation, so the mean square deviation is sometimes referred to as the variance. So that's the concept. From that table, we can be able to derive the mean value deviation, which is abbreviated using the square of s, and therefore we can give it or allocate to it a different name or another name that is known as the variance. Now, the square of the variance is called the standard deviation. So therefore, the square of this variance is what we call the standard deviation. So suppose we try to expand this set of a formula, general set of a formula, and try to see how we can be able to represent this new concept that we call the standard deviation. So in actual sense, for our measure of variability and dispersion for today, our main concern, of course, we were trying to learn about this standard deviation. our previous recap that we've already mentioned. So I'm going to do away with this, but we're going to try and create an emphasis for what we have discussed and try to find out how we can be able to calculate this standard deviation. So I'm going to divide the board into two parts so that we can be able to use and derive this aspect, or maybe the aspect of standard deviation that we talked about. Now we have given the mean square deviation as the summation from I to n over fi, the division of absolute values from I to that one squared, and then we have the summation of frequency from I to n. So therefore, trying to work on this formula, we will have this is a general representation of that. Of course, we have this one and still have the same value. So we are going to expand this one using the normal algebraic concepts, and then we will find the square of this is going to represent 2xx plus x squared over the summation of frequency. So therefore, expanding this is going to give us the summation of fx squared over summation of f minus 2 the summation of fx x bar, which is our mean, the summation of frequency, plus the summation of fx bar squared over summation of f. So we are trying to expand this formula and see whether we can come up with a simplified form of how we can be able to find what we have defined as the mean square deviation. So therefore, this is going to give us just do a simplification for these first two parts of the formula, and then we shall have fx squared over the summation of f minus 2x squared for the mean plus x squared. Now the second part of the equation, of course, this part comes from the fact that if we try to look at this aspect of the formula, this stage, this one basically defines the mean. That is why the second part is a mean squared, which gives us that part of the equation there. So therefore, this equation is going to reduce into a form that is the summation of fx squared minus the square of the mean divided by the summation of frequency. So this basically is going to give us a s squared, and we have defined s squared, the mean value the mean square division, which is called the variancy, as the last part of this formula. Now for that case, we have said that the standard deviation is the square of the s, the square of s is the root of s, which has been given. So let me try to do that. So variancy, which is given as s squared, and then we have said about this is the mean. This represents the mean square deviation. Now the root of the mean square deviation gives us what we call the standard deviation. Therefore, the standard deviation is going to be the root of this particular formula, and therefore we're going to represent it using this formula here. So therefore we see the standard deviation is equals the root of summation of fx squared minus summation of the mean squared divided by the summation of frequency. So this is the formula that we use to give us this aspect of what we call the standard deviation. And this standard deviation is a convenient way of course to work with because it uses the same units as the raw scores that we have been given in a set of data. Now if the scores appear with the different frequencies as we have said, then it's going to assume the general formula that we've already written on the board. And I'm going to use one of the examples for illustration of the above, so that we can be able to work out one of the examples and find out how to calculate the standard deviation for a set of data. So in that case, I'm going to do away with this and give that illustration for a table that we shall use to find the standard deviation for a set of data. So I'm going to use that. On my right side of the board, I have a set of data that is, of course, of a number of students against the marks that they scored in maybe one of the subjects during their examination. So in that case, the first column that we have there is the mark. The second one is going to be the number of students. The third one is going to be, of course, that range of data that we're going to see there, the number of students who scored, or whatever they scored in their marks. And then we are going to see the product of the frequency times that number of marks that was scored within that range. And then we are going to have the last column, that is the square of that data times the frequency. Now in this case, we have said that for us to find the standard deviation, we use this formula, which is the square of the mean square deviation, summation of fx squared, summation of the square of the mean, summation of the frequency. Now we have a table for this column. This is the last one, and then we'll of course use that to find the mean, and we find the square of that mean. So I'm going to write that the summations for those different columns below that one. We do a calculation to confirm that, but hope that the figures will just be right to do an illustration. So in this case, the summation for the total frequency, the number of students is 50, and then we find that the product of the frequency times the number of the marks scored is going to be 1370, and the summation for the fx squared is 45,850. Therefore, for us to find the mean, we say that the mean is given as the summation of fx over the summation of f, which is going to give us 1370 divided by 50. So the mean, our x bar is going to be 27.4. So therefore, we just have to write it somewhere, since we need that one. So x, that is the mean, is 27.4. Now let's try to find the value of x squared, x bar squared. So it's the value of this one squared, which is going to give us 750.76. And then we are going to use this formula to find the standard deviation, which is the root of summation of fx squared, which is this one. Now that one is 45,850 minus 750.76 divided by summation of f 50. So this one is going to give us a standard deviation as 12.89. So basically what is required of us is to be accurate on these figures, and maybe I request us to try and do a calculation and confirm whether the figures that we're getting here is basically the correct one. But in that case, this is the standard procedure that we're going to use in calculating the standard deviation. And as we have said, this standard deviation is very essential because actually it is very essential to work with, because it uses the same units as the raw scores in the data that we have been given. So for that case, this is the end of it for today. I hope that this concept of the standard deviation has been understood and we can be able to apply it appropriately whenever required to. So that's it for today, guys. Thank you. Bye. God bless.